also do a default amount, which we'll set to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, which is going to be 0.1 link. So first, let's get an account. We'll say account equals, we're going to do a little clever Python stuff here. We'll say account equals the account if somebody sent it, if account. So we're saying the account that we use is going to be this account thing if this account thing even exists. Otherwise, we'll call our get account. Otherwise, we'll just do our regular get account function. Then we'll do the same thing with the link token. We'll say the link token is going to be equal to the link token that somebody supplies as a parameter if they applied something as a parameter. Otherwise, we'll just do that get contract stuff that we did before of the link token. Now that we have this link token contract from our get contract function, which again is basically the equivalent of doing, this contract.fromABI on our link token, pulling from our config or from our mock, now we can just call the functions on this link token. So we can say our transaction equals link token dot transfer. We're going to transfer token to the contract address with a certain amount. And of course, we'll do from account. We'll do tx.wait. And then we'll do print funded contract. And then we'll even return that transaction. I do, however, want to show you another way to work with this using the interfaces. Instead of doing this link token.transfer directly on the contract, we can use this interfaces section to actually interact with some contracts. So right now we have our mock link token here, which is great because it has all the definitions and all the functionalities defined in here. Sometimes you're going to have contracts that you don't have everything. You don't have all the functionality, and maybe you only have the interface, maybe you only have some of the function definitions. So we can still interact with contracts with just an interface because, again, that interface will compile down to our ABI. So as another way of teaching us how to actually work with some of these contracts, what we can do is we can use the link token interface basically the same way as we use the link token contract here. So again, I'm in my chain link mix because there's already a link token interface in here. And this will compile down to a way that our Brownie package knows how to interact with these contracts. So if you wanted to, we could just grab this, go to our Brownie section. We'll do a new file in interfaces. We'll call it link token interface.sol. We'll paste it in here. Save my auto formatted here. And what we can do in our helpful scripts instead is transaction equals interface. And we can also just import interfaces right from Brownie. Interface dot link token interface. And we just need to give it a contract address. So we can say link token dot address. Or excuse me, we can say the link token contract equals interface dot link token interface, link token dot address. So this is another way we can actually create contracts to actually interact with them. So we saw up here this contract.fromABI, which is great. This is another way we can do that exact same thing. So then we can just do link token contract.transfer, contract address, amount from account. So this is tx equals. So this is another way to actually interact with contracts that already exist. You're probably starting to see that Brownie has a lot of built-in tools that make it really easy for us to interact with contracts. If we have the ABI, we can just pop it into contract.fromABI. And again, with the address and the ABI, and then just give it some name. If we have the interface, we don't even need to compile down to the ABI ourselves because Brownie is smart enough to know that it can compile down to the ABI itself. And we can just work directly with that interface, which is incredibly powerful. For now, I'm going to comment these two lines though, and we'll just use the link token.transfer for now. Now that we have a funding script or a funding function, we can import this from our helpful scripts. From scripts.helpfulscripts, import get account, get contract, fund with link. And we can just call in our end lottery function. We'll do fund with link and parameters. We only really need a contract address because the way we set this up will just automatically grab a default otherwise. So we can say lottery.address, and that's it. And that's all we need. And then I know we're doing tx.wait right in the fund with link, but just to be verbose here, we'll get the transaction from the fund with link, and we'll do tx.wait here as well. And then once we're funded with link, then we can go ahead and call our end lottery function, because again, this is going to call that request randomness function from the Chainlink VRF. We'll do ending transaction equals lottery.end lottery. And all we have to do is from count, do ending transaction.wait 1. So from our end, this is really all that we need to do, right? But remember, when we call this end lottery function, we're going to make a request to a Chainlink node, and that Chainlink node is going to respond by calling this fulfill randomness function. So we actually have to wait for that Chainlink node to finish. Now, typically it's within a few blocks. So normally what we can do is we can just do a time.sleep for something like 60 seconds. And typically in that time, the Chainlink node will have responded. So we'll just do import time at the top, time.sleep, and then we can see who that recent winner is, if that Chainlink node responded with a recent winner. So we can say print f lottery.recent winner is the new winner. All right, now, of course, for those of you who are thinking ahead a little bit, you might be thinking, hey, well, there's no Chainlink nodes watching our local ganache. And you're exactly correct. So what happens when we add our end lottery function to our main function here? Do you think that we're going to actually get a recent winner back? Why or why not? What do you actually think? Well, let's give it a shot. We'll do brownie, run scripts, deploy lottery.py. So we're doing a lot of transactions here. We've started the lottery. We're entering the lottery. You entered the lottery. We're sending some link token. Now we just called the end lottery function. While we're waiting here, this is when the Chainlink node would go ahead and start responding with our randomness. However, as you probably astutely guessed, there's no Chainlink node that's going to call this fulfill randomness function right now. So for our Grenache chain, this will hypothetically end with nothing, right? Because there's no Chainlink node actually responding here. 0 is the new winner. Of course, this means that the Chainlink node actually didn't respond because there is no Chainlink node on our local Grenache. For our testing purposes, we're going to figure out how to actually get around that and deal with that. Awesome. It looks like we have everything set up to be successful in our lottery here. But we want to do our due diligence. We want to make sure that our tests are really solid on a development chain before we actually test this on an actual testnet. So let's jump into some of these tests. We've already started with this test lottery.py bit here, but we're going to iterate on this and make this even better. Now, before we get into these tests, there's a couple things we want to talk about here. And that's going to be integration tests and unit tests. Unit test is a way of testing the smallest pieces of code in an isolated system. And we're going to use it to loosely define testing independent functions in our lottery contract. We also want to do what's called integration testing, which is going to be testing across multiple complex pieces. Typically, I like to run my unit tests exclusively on a development environment and my integration tests on a testnet. This is really helpful because we can test the majority of our application, like we said, on a development network, and then still be able to see what actually happens on a real testnet and see what happens on Etherscan and everything like that. Typically, what people do is in their test folder, they'll create 2 different folders, one for unit and another folder for integration. Since for this demo, we're only going to have one file for both, I'm just going to go ahead and not create these folders, but it's a pretty common practice. Instead, what I'm going to do is I'm going to rename this. I'm going to hit enter to rename it. I'm going to do underscore, type unit for unit tests, and we're going to create a new file called test lottery integration.py. So this one, we'll do our integration tests, and in this one, we'll do our unit tests. Now, when writing unit tests, we really want to test, hypothetically, every single line of code in our smart contract. This is incredibly important, of course, because smart contracts are open to everybody to see and interact with. So we really want to test every single line of code we have in here. So let's go ahead and finish writing a get entrance fee test that will work on a local development network. As you can see, we're already going to have to refactor this from what we originally had. Let's go ahead and just delete everything under here for now. We already learned so much more from there. All right, so how are we going to test this get entrance fee function now? So first, we're going to want to deploy our lottery again. Since we have a deploy lottery script already, we can just use this deploy lottery script as well. If we wanted to, we could just copy paste this whole part into our test, but we're just going to go ahead and work from this deploy lottery script. So we're going to import this, and then we can actually even get rid of this from Web3 line for now. We can get rid of these two comments too. And we'll say from scripts.deploy lottery import deploy lottery. And on this deploy lottery function, we'll just say lottery equals deploy lottery, and we will return our lottery. Now in a unit test, we'll say lottery equals deploy lottery. And this will give us our lottery contract. Once we have our lottery contract, we can just call this get entrance fee. So we can say entrance fee equals lottery.get entrance fee. And oops, let's just make sure we're doing the arrange act assert mentality here. And we're going to want to make sure this entrance fee is what we expect it to be. So what do we expect it to be? Well, again, our helpful scripts is going to deploy these mocks, right? It's going to deploy this mock, and the initial value is this 2000 number. So if the price of ETH here is $2,000 ETH feed, and the USD entry fee is 50, we'd say 2000 over 1 is equal to 50 over X, which is going to be equal to 0.025. So we can go ahead and even do this math here. We can say expected entrance fee is going to be equal to 50 divided by 2000. We'll just do 0.025, but we'll do this in way. So we'll do from web3 import web3. We'll say this is web3.2 way 0.25 ether. And now we'll assert our expected entrance fee equals the entrance fee. And now to test this, we'll do brownie test-k. And perfect, this is working exactly as we anticipated. So that's awesome. Now, as we mentioned, since this is a unit test, we really only want to run this when we're working on a local environment, a local blockchain environment, or a local development network. So we'll go ahead and do this with PyTest again. Say if network.showActive is not in local blockchain environments, PyTest.skip. Of course, we're going to have to import PyTest. We're going to have to import this local blockchain environments from our scripts.helpful scripts. My VS Code automatically added that bit here. Now, if we try to run this, brownie test -k get entrance fee -network rinkb eb, it should go ahead and skip this. Perfect, and that's what it does. What's the next piece that makes sense here? Enter is going to be one of the first things that these developers do. So let's do test def test enter. But let's even be more specific than that. We don't want people to be able to enter our lotteries unless the lottery is actually started. So let's make sure that this line actually works. So we'll call def test can't enter unless started. And again, we're only going to run this on a local development chain. So we'll just copy paste this section down here. We'll say lottery equals